There are 6 trigonometric functions, and there are different methods of defining them. Probably the most straightforward definition is based on right triangles. So let's start with that one. The idea is that we will input an angle measure into a function, and it will output a number. So for the moment, let's just call our first example function f like usual. And we're going to input an angle. You could use either degrees or radians, but when we work with triangles, we usually use degrees. Technically, we're actually inputting the measure of the angle, like 35 degrees, not, the physical geometric angle itself. But just for convenience, I'll often just say we're going to input an angle. The function output is going to be based on measurements from the sides of a triangle. Our first task is to find or create a right triangle that contains our input angle. Since a right triangle always includes a 90-degree angle, our input angle must be one of the other two. So, for instance, if we want to input a 35-degree angle into a trig function, I could draw a right triangle like this one with a 35-degree angle here. Next, we need to measure the lengths of all 3 sides. We're not going to be able to get exact measurements usually, but I'll use a ruler and be as accurate as I can. We'll need to refer to the different sides of the triangle, so let's name them. The longest side, the one that is opposite the right angle of the triangle, is always the hypotenuse. The other 2 sides are called the legs. One of the legs touches our input angle and the other one doesn't. So we'll call the one that doesn't the opposite side, and the one that does is called the adjacent side. But wait a minute, what if we each draw a triangle and our triangles are different sizes? Then we're going to have different side length measurements, and won't that mean we get different answers for whatever we're trying to output from our triangles? If you tried to create a function where the output number was just, say, the length of the hypotenuse, then yes, we would indeed get different answers, and this correspondence would not work as a function. But the trig functions use more than one of the length measurements. In fact, they create outputs by making ratios, in the form of fractions, from 2 of the side measurements. And the side measurements stay proportional to each other in any triangles that have the same angles. So, fortunately, the size of the triangle won't make any difference. Now there are 3 side lengths in our triangle, and we're going to choose 2 measurements at a time to create outputs. And there are 6 different ways we can form fractions that way. We'll use all 6 of these options to create outputs for 6 different trig functions. The first function we'll talk about is the sine function, written sin for short. So instead of using f for our function notation, we'll use sin. And if we used a Greek letter as our input variable, the letter theta is a common one, then sine is the name of the function, and the output is represented by sine of theta. We'll often leave out the parentheses just as a shorthand way of writing it. So in our current example, we're going to input 35 degrees, and this is how we'll get our output number. We take the length of the opposite side in the triangle, and we divide it by the length of the hypotenuse. We'll use HYP for short to mean the length of the hypotenuse, and similarly OPP is the length of the opposite side, and ADJ is the adjacent side length. So then we can say sine theta equals opposite over hypotenuse. According to the measurements I made, we would have sine 35 degrees equals approximately 5.3 divided by 9.2, which is about 0.58. Now my length measurements weren't perfect, so this output number isn't completely precise either, but it should be pretty close. And no matter what size triangle someone may draw, if they measure the sides pretty accurately, they should also get an output number pretty close to 0.58. You may feel a little uneasy about values that we keep saying are pretty close. Well, calculators can compute trig function values as well, and much more precisely than what I'm getting here from my triangle. According to my calculator, sine of 35 degrees is 0.573576, and the numbers keep going. So, by the way, how is the calculator getting such an accurate number? Is it measuring triangles super carefully? Does it have all these values already stored in its memory? No. The actual value of sine of 35 degrees is a never-ending decimal number with no repeating patterns, an irrational number, as we say. No one could ever write the entire thing down, and yet calculators can give us 10 digits or so, and computer software can give us as many digits as we want. So how are they doing this? There are sophisticated methods using calculus that can generate the sine function value of any input angle. They use an algorithm with a never-ending list of steps, and the more steps you complete, the closer your number gets to the actual true value. If you take a calculus class or two, you'll learn about a topic called infinite series, which is one of the ways this is done. So you've got that to look forward to.